want to talk about the exchange. I want to talk about the exchange of value between everything around us and everything inside us. This is the simplest formula that can get the patient n as the thing all around us and delta t as the thing inside us and close to us. These are all the things that are around us, but this is more of a broad term like space and time. Actually, time is included in both of this. Time is flowing through our body, and time is flowing all around us from space and everywhere, except some parts, and I want to talk about that. So, the parts that time is not floating, there are different kinds of boundaries in space. In space, like countries, there are boundaries where other boundaries cannot pass, and certain objects cannot pass those boundaries. Two boundaries, there are three boundaries. The first one Automorphic boundary. Second one Isomorphic boundary. Third one Conformal boundary. These three boundaries cannot pass each other. The certain things are so we can put this anything, we can put this as conformal, we can put this as conformal, but let's say there are three types. Let's say this is automorphic, this is isomorphic, and this is conformal boundaries.
What is difference?
I'll talk about it. So the automorphic boundary is, I don't know the root words, but I know the difference between an isomorphic conformal boundary and an automorphic boundary. Do you know what that is?
No, I don't know.
So, automorphic boundary is a boundary in space where scientists thought that ether was only filled, and scientists said that those parts were automorphic boundaries. But then, in that, there are dark matter and other substances that cover 32.63% of the space, and those parts are included in the automorphic boundary. And the automorphic boundary, why they have the name is, it's not that isomorphic boundary is inside the automorphic boundary, but the part of isomorphic boundary and the part of conformal boundary is plussed and mixed, and then mixed with other kind of substance like ether or those kind of dark matter things, and it makes the automorphic boundary.
Ether? What is ether?
Ether. So scientists said that ether is a part in space where it is empty, but then Einstein said that no, they said that the empty part is called ether.
It's like a vacuum? Vacuum?
No, it's just nothing. Actually, it is nothing, but the scientists thought that substance called ether is inside there. But then Einstein said that actually there's no ether and it's empty actually. But then there is actually ether. It is existing inside the automorphic boundary. But the thing is, automorphic boundary can exist in state of 0 and infinity, both. So when the automorphic boundary is not existing, it is existing in somewhere else where we cannot predict. And when it is existing, it is not existing in where we cannot predict. Yes. Isomorphic boundary is isomorphic boundary is the place where there's a very small hole inside the boundary, and inside that hole it's like a vacuum, and it's a cylinder shape, probably a cylinder shape, we don't know, but it is probably a cylinder shape, and it is gathering all the mixtures of elements, all the particles like axion, boson, fermion, and is what I've talked about in the past lecture. Those are all gathering in one small hole, and they are not escaping from there. But there is a hole inside the conformal boundary too. But the critical difference is that the isomorphic boundary, the particles are stayed inside the hole, but the conformal boundary, the particles go inside the hole and go outside the other side. They don't keep trapped. They're not trapped inside the hole. They are released to the other side. But this one is trapped, isomorphic boundary.
Why did you explain 3 types of boundaries today?
I wanted to talk about this.
What is the main purpose of today's lecture?
Time.
Time?
Yes. Time and the relationship between space. Space boundaries. These 3 boundaries I want to talk about. So now what I'll do is, let's say that we put a time, do you know time's flow? Do you know?
Everybody knows.
No, everybody doesn't know.
Why?
Everybody.
Is there anyone think time is stopped?
I'm not talking about that. Look. Time existing in space. Look. So time existing in space, space, do you know matrix mechanics?
What is matrix mechanics?
It's by Heisenberg, and it's matrix in all kind of value. Everything is metric. It is divided in a Bjorn, and the Bjorn can curve.
Plane? Flat?
Surface?
Surface.
Surface? Or?
It can curve, and so that's metric. So in matrix mechanics, there is a surface that has the volume of 0. So it's not existing, but when we put it inside the 2D, it exists. It's like, let me show you an example. If we draw, so is a triangle. Is triangle's all angle, if we add it up, is it 180 degrees? What do you think? What do you think?
I don't know.
It's not. It depends. If we put it in 2D, and then it's 180 degrees. If we draw it, if we go on the sand and draw a triangle, actually the triangle will be like this, kind of. It'll be over 180 degrees, of course, right? because the Earth is a sphere. Similar to that, the surface is 0 inside this space because this space has a volume, but inside 2D and this, I don't know why, but in space it also is considered that has volume, because in 2D nothing has volume, but in space there is volume, but time has volume too.
Time's up.
No. And
I'll give you just 5 minutes.
and the flow of time
Audition of
can
5
be
minutes.
represented as this.
Please wrap up the lecture.
And another one is and this one is the first. This is a formula that time travel. This is substance. This is surface. This is surface, and this is when time goes below the substance, and this is when time goes over the substance, and this is when time goes through the substance. Like this, with this formula, if we put time here, and of course there's a flow in everything. So right now the flow is this, and time will go like this, or like this, or like this.
Donut?
Yes, donut.
Just kidding.
But then the problem is that time doesn't go over the radius. Maybe this length is 2, but this length may be 5. And it could go like this. And that causes, inside the isomorphic boundary, this causes universe to come out in isomorphic boundaries. And why I talked about ether in automorphic boundary, because automorphic boundary is actually a boundary with no holes. So that's why it's different. But actually, they say it's ether. Ether. And why there is, because when time goes, same as particles like electrons, fermion, boson, and axion, the time will get trapped inside here, and then it'll get bigger and bigger and bigger and bigger, and then the stars that are next to time will, and the stars that are next to time, those stars' time will slow down. Do you know what I'm talking about? CWISE plus 1315 is a star. CWISE plus 1315 is a star that is heading to our Milky Way, to our solar system. And that star, why is it coming? It was a binary star. Binary star that goes, it may be the oldest star we ever found. Because the bigger star was absorbing all the time from, because it's a binary star, they go like this. And the bigger star is absorbing every time and getting bigger and bigger and bigger and bigger, and this is getting smaller and smaller and older, because the time is all getting taken by it, and this star is getting bigger and bigger and younger and younger. Benjamin's opposite life.
멋있다.
And then this pops, supernova, releases gold.
I know supernova.
슈퍼노버.
Supernova.
It releases gold. Supernova releases gold. Do you know? And the gold sticks to the binary star, and because the force, it went, and then it coming toward our solar system, Earth. And when it lands on Earth, Earth will collapse, and then gold will what every body wants.
Can you finish the lecture in 1 minute?
Like that, time could be taken like that. So time is getting bigger and bigger and bigger, and the isomorphic boundaries pop and becomes conformal boundary. I mean automorphic boundary, because there's no hole now. But then the outside is never gonna come out.
Thank you.